Welcome to Summarize Science. Have you ever wished you could just reach into a photo and pull out an object? Today, we're looking at a new AI from Meta called SAM3D that can essentially do just that. This system can take a single, ordinary 2D image and generate a complete, composable 3D scene from it. As you can see here, it identifies individual objects like a lamp, a chair, or a plant and reconstructs them as high-quality 3D assets. For years, this has been a huge challenge in computer vision, mainly because of a massive data shortage. To teach an AI what a fire hydrant looks like in 3D, you'd ideally need thousands of photos of fire hydrants paired with perfect 3D scans, which is incredibly difficult to get at scale. Previous models mostly trained on clean images of isolated objects and struggled with messy, real-world scenes where things are hidden or cluttered. SAM3D's creators tackled this data barrier with a clever multi-stage training process. First, the model learns the basics of shape and texture by studying millions of synthetic 3D objects rendered in isolation. Then, in a mid-training step, these synthetic objects are digitally pasted into real photos. This teaches the model how to handle context, background clutter, and objects partially blocking each other. But the real magic happens in the final stage, which aligns the model with the real world. They created a human-in-the-loop data pipeline that is truly a game-changer. Instead of the impossible task of asking people to create 3D models from scratch, the AI generates several different 3D options for an object in a photo. Human annotators then simply look at the options and pick the one that looks the most accurate. This process of choosing the best option is fast, scalable, and creates a virtuous cycle. The chosen models become new, high-quality training data, which is used to improve the AI. The improved AI then generates even better options for the humans to choose from, and the cycle repeats, rapidly boosting the model's performance. For the most difficult cases, they even brought in professional 3D artists to create ground truth models. The results speak for themselves. Here you can see a qualitative comparison against other leading models. Notice how SAM3D correctly completes the shape of the chair that's partially hidden by the table, whereas other methods get confused. It consistently produces more accurate and complete shapes, even with heavy occlusion. The quantitative results are just as impressive. This chart shows human preference rates, and it's not even close. In head-to-head comparisons, people preferred SAM3D's reconstructions over the competition by a massive 5-1 margin. So, let's recap the breakthroughs here. SAM3D can generate a full 3D model, including texture and layout, from just a single image. It excels in cluttered, real-world photos where other models fail. And it was made possible by a brilliant data collection strategy that uses human preference, rather than human creation, to rapidly improve the AI. What could this mean for the future? The possibilities are huge. Imagine creating assets for video games or virtual reality just by taking a picture. It could give robots a much deeper understanding of the objects in their environment. This technology could also revolutionize online shopping, allowing you to view any product in 3D or power augmented reality apps that seamlessly blend the digital and physical worlds.